Again, good morning, grade 10. Since your fourth mastery test is fast approaching and we are still in the introductory part of the lesson, we need to move forward. Examples will follow after the discussions, alright? Is that okay?
Okay, teacher.
Because it
Yes,
takes time
sure.
to have the examples, but if this is face to face, why not? It's really easy. Okay, we can even generate our own formula out of the base formula, right? Let's move to Charles' law. Okay, the volume and temperature. Jacques Charles duplicated the experiment done by Joseph and Tien Montefolger in on June 4, 1783 in Annonay, France. They are French actually. He used to fire inflate spherical balloon about 30 feet in diameter and travel about 1.5 miles before coming back to Earth. So this is now the birth of your hot air balloon. Okay. Charles found out that the volume of gas is directly proportional to its absolute temperature under constant pressure. So the volume of gas is directly proportional to the temperature, okay, which is V over T, or volume over temperature, is equal to the constant. So this is the formula, right? Take note that these are the base formula. So we can generate a lot of formula out of the base formula, right? The temperature in which V is constant or absolute zero is equal to zero. Absolute zero is the lowest temperature possible. Okay. By the way, the temperature here, or the lowest temperature possible here, is in Kelvin, right? It is not in degrees Celsius, but it's in degrees Kelvin. By international agreement, absolute zero is defined as 0 Kelvin. On the Kelvin scale, it is negative 273 degrees Celsius on the Celsius scale. Kelvin is a temperature scale named after Lord Kelvin in 1824 to 1907, which each Kelvin is the same size as the Celsius degree. Okay? To change degree Celsius into Kelvin, you will just add plus 23, 273 rather. Okay, again, to change degree Celsius into Kelvin or degrees Kelvin, you need just to add 273. Like for example, if you have 75 degrees Celsius or centigrade, if you're going to convert that one into degrees Kelvin, it is plus 273. That is your degrees Kelvin. In comparing the same substance at the same pressure under different sets of condition, the law can be expressed as V1 over T1 is equal to V2 over T2. Can you see now the resemblance of the previous discussed topic? They're actually relevant. Now, if you're going to look at the formula, that is why this topic, the gas laws, is connected to each other. Okay? They are really connected to each other. Okay, let's move forward. When a fixed mass of gas is heated at a given pressure, the volume increases because molecules move faster and expand. Okay? If you're going to apply also heat there, tendency is you are actually increasing in volume because the molecules of air move faster because of heat and expands. Charles' law explains the following phenomena or application. Your hot air balloon, when heated to flame, the balloon expands, making it less dense than the surrounding cool air. Thus, the balloon rises. Okay? Because you're creating pressure. Okay? Rising smoke. Smoke is than less dense than the surrounding air, hence it rises. Heat from the flame causes smoke particles to move rapidly, increasing the volume it occupies, thus lowering its density. So the smoke rises because it is actually less dense than the air in your surroundings or environment. Swelling rubber. Slightly inflated rubber life raft slightly swells when left under the sun. Heat from the sun causes the gas molecules to move rapidly and farther apart from each other. So, the rubber swells under the heat of the sun. Amonton's law, pressure and temperature. Okay? Gullion or Guglielmi, Gullion, those are the pronunciation. Amontons investigated the relationship between pressure and temperature. Do you have any questions so far? Grade 10.
None so far.
Please let me know if you have questions so that I can address your concerns, right? Again, investigated the relationship between pressure and temperature in gases. He discovered that the pressure of a fixed mass of gas and fixed volume is directly proportional to the absolute temperature. Okay? We're talking now temperature and pressure, the relationship between temperature and pressure. Okay? He discovered this while building an air thermometer. Amonton's law can be expressed mathematically with the formula P, or pressure is directly proportional to temperature. Okay? Or P is equal to C, or constant, times time, or temperature rather, or pressure over temperature is equal to constant. So those are just the base formula. No? Do not be confused with those formula simply because these are just base formula. Okay? Depending upon the given, you need to formulate your own formula out of the base formula. It's really easy. In some chemistry books, the pressure-temperature relationship is referred to as Gay-Lussac's law. Okay? Sometimes they use Gay-Lussac's law. Sometimes they use these terms, right? So these are just the same. Okay? In comparing some same substances under different sets of conditions, the law can be written as P1 over T1, or pressure 1 over pressure or time temperature 1 is equal to pressure 2 over temperature 2. Okay? Can you see now the relevance? It is also relevant to the previous discussed topic. Okay?
Hi, teacher.
The relationship between pressure and temperature can be explained by the kinetic molecular theory. There you go. So this is because they are actually related to each other simply because it is actually explained in the kinetic molecular theory. Okay. Which I had already given in the introductory activity, the kinetic molecular theory. This theory is really long. That is why we will be talking about kinetic molecular theory after these gas laws. Amonton's law explained the following phenomena. There are more flat tires during summer, correct? Temperature is high during summer, thereby causing the increased pressure inside the tires. Okay? Or, have you seen the race, no? These fast cars, they need to change tire, I think around 2 rounds in a constant speed with a fast speed simply because the temperature there is high in the tire and it might explode. Okay? Throwing an can, aerosol can into fire can cause it to explode. High temperature causes gas in the aerosol can to exert more pressure. Correct. Remember that your aerosol can also builds pressure inside. It is actually it has pressure inside its can. Aerosol sprays ba? Like for example Baygon, those are just those are aerosols. Pressure is adjusted in tires before a trip. The flexing of tires while driving increased temperature of gas inside the tire, thus increasing the pressure. So, if you're going to observe, if you have drivers and even your family members adjusted the car itself, the tire itself, before a long trip, This is because um, air inside will expand if there is heat. Okay, it will increase its pressure. That is why they tend to adjust the air inside your tire. Dipping distended ping pong balls in warm water. Hot water raises the temperature of air inside the ping pong ball, thereby causing the gas molecules to move faster, which in return increase pressure. Okay. Ping pong balls. Kanamang malumping imong ping pong balls. Okay. They tend to put it in hot water. Okay, why? This will allow the air inside the ping pong balls to rise or to increase in pressure, thus returning it to its original form. Okay. Operation the pressure cooker. Pot pressure cooker is well sealed pot. It does not allow the steam to escape. The steam builds and creates pressure. Right, that's about 10.34 newtons per square centimeter. Water under high pressure boils at high temperature. That is about 121 degrees Celsius or 250 degrees Fahrenheit. Than the normal boiling point of 100 degrees Celsius or 121 degrees Fahrenheit. Due to higher temperature, the food gets cooked faster. The pressure cooker contains mainly three parts: the pan, the lid, and the accessories. So, this is how your pressure cooker also cook food. Remember that the boiling point of water is 100. Okay? The rising of pressure inside tends to what? To penetrate on the food that you're trying to cook. Okay? Making your food gets cooked faster, right? This is because of pressure. Combined gas law. Okay. Recall that Boyle's law is pressure times velocity or volume rather, is equal to constant. Charles' law is volume over temperature is equal to constant. Among tons, it's pressure over temperature is equal to constant. Okay? Hence, we can have a combined gas laws. Okay? This is the combined. With the three gas laws, we can express the formula pressure times volume is equal to temperature. Pressure times volume over temperature is equal to constant. By comparing the same substances under two different sets of conditions, we can have this formula. Okay? Pressure 1, volume 1 times volume 1 over temperature 1 is equal to pressure 2 times volume 2 over temperature 2. Okay? Can you see also the resemblance? Actually, they are the same if you're going to look at it, right? It is just a matter on how we formulate the formula. Okay? Just give me a minute. Okay, let's move forward. Are you still with me, grade 10?
Yes, sure.
Right. There is a standard set of conditions for experimental measurement to enable computations between sets of data. This is referred to as standard temperature and pressure, or STP. Okay. Let's tackle about STPs. Avogadro's law. Okay. Volume and amount. If you're talking about Avogadro's number, you're talking about volume and the amount of molecules. That is actually with Avogadro, right? Amadeo Avogadro proposed that the equal volumes of gases at the same temperature and pressure contains the same number of molecules, regardless of their chemical nature and physical properties. This is now known as the Avogadro's law. Okay? Mathematically, it is expressed as um, volume is directly proportional to N at constant pressure and temperature. And there stands for the number of molecules. Or volume is over N, or the number of molecules. Volume divided by the number of molecules is equal to constant. Okay, let's move forward. 1 mole of any gas consists of 6.02 by 10 to the power of 23 molecules, known as the Avogadro's number. This is constant. Okay, this is constant wherever you go, even in your college, even in senior high. So this is the Avogadro's number. It is the number of molecules of any gas present in a volume of 22.4 liters. In summary, 1 mole of ideal gas occupies 22.4 at STP. So what is STP then again?
Standard of temperature and
Okay, standards of temperature and
pressure.
pressure. Okay, the volume is referred to as the molar volume. So this is the molar volume. Per mole occupies 22.4 liters in standard, right? Ideal gas law. Okay. Recall the three base laws. This is base. We have Boyle's law, which is volume is inversely proportional to pressure, which is constant N and constant temperature. Charles law, which is directly proportional to temperature, which has we have constant N and constant P, or pressure. Avogadro's law is directly proportional to the constant, or to the number of moles. We have constant pressure and temperature. These relationships can be combined in a single relationship. Yes, correct. So, if we're going to combine those, volume, because Avogadro is talking about volume also, volume is directly proportional to number of moles and temperature, or time, or T. Okay? Wherein V, wait, this is wrong. Let me check. Volume is directly proportional to NT over P. Okay, this is over P, over pressure. Hence, volume there is directly proportional to R. What is R? Okay, proportionality constant. R is NT over P. Okay? Can you see now the concept? Can you see the concept now? Let me annotate. This is the combined formula, right? Di ba we have volume is directly proportional to N over N, or number of moles times temperature, over P. Okay? If you're going to combine this one, it will form R, because R is NT over P. So this,
So it so teacher, the R is the result of the NP over P.
yes, okay, this is the proportionality constant. Okay. So, tingaling maglibog mo sa formula ba? It's really easy. No, it's a matter of concept.
Excuse me, sir.
Yes.
So that formula below, what I mean, the NT over P is disregarded. It's not, no, it's not included in the formula, or is it included?
It depends upon the problem itself. That is why you're given the base formula. Because
Okay.
it might be that the proportionality constant there is given, or you need to calculate for the proportionality constant. That is,
Okay. So, Kon, do you mean if the R is completely given, and then we will have to find V, that will be, we will be using the V, then the infinity sign, then R.
yes.
But if the R is not completely given, like example, we lack pressure, and then the volume is given, we will have to use the first formula.
Yes. Correct, child.
Okay,
That is
okay,
why
thank
it depends upon the problem. So, that's the reason why I already given you the base formula. Okay. Some books, they don't actually give you the base formula. They just give you directly the formula. But it is not teaching you how to fish. It's giving you the fish. Okay? This is now teaching you how to fish. This is teaching you how to get the formula out of these base formulas. Diba? It's really easy.
It's understandable po.
Yes, correct.
That's me.
Right? Do you have any questions so far?
None so far.
Not so far.
Right, so let's
Or
move forward. Rearranging. We can rearrange again. Okay? Pressure times volume is equal to moles times R, your proportionality constant, times temperature. Okay? Again, temperature is expressed in degrees Kelvin or Kelvin. Okay? Actually, you can generate a lot of formula out of those base formulas. Okay? All you have to do is to think about what are the given and what are the concepts behind. The value of R is computed in the following, again, same. The amount, the PV, or pressure times volume, over the moles times temperature. Okay? The ideal gas is defined as one in which all collisions between atoms and molecules are perfectly elastic and there are no intermolecular forces. Because if there is an intermolecular forces acting on it, then it says there is a chemical reaction. Okay? At normal conditions, such as standard temperature and pressure, most real gases have qualitatively like the ideal gases. Ideal gas model fails at a very low temperature and very high pressure when intermolecular forces and molecular sizes become important. We will be talking about molecular sizes and intermolecular forces when we will have our chemical reaction. Dalton's law, okay, of partial pressures. John Dalton in 1766 to 1844 found that the pressure exerted by the mixture of gas is equal to the sum of the partial pressures of the gas or gases present. This is known as the Dalton's law of partial pressures. By the way, for your fourth mastery tests, there is no computations there yet, simply because we are still in the discussion, right? Even though we will not, we cannot finish, or we will not finish the topics or the concepts are already in your module. All you have to do is to download your module and study your concepts. So this is now the coverage for your fourth mastery tests, the gas laws. Okay. I even did not include the computations. Okay. Those are just purely concepts, right? In equation, the pressure of mixture can be summarized as pressure is equal to, or total pressure is equal to pressure 1 plus pressure 2. Simple concept. Wherein PT, or the total pressure of the mixture expressed in millimeter of mercury atmospheric pressure, or torr. P1 is the pressure of gas 1 and the pressure of gas 2. Okay. These are just basic. Okay. So far, we had just tackled um, the gas laws. All you have to do now is to gather all the formula. You need to gather all the formula and familiarize the formula, right? By next meeting, hopefully, we can have the review of these gas laws, these concepts. Do you have any questions so far?
None.
None so far.
Okay, since we still have, I think we have 4 minutes left. I'll be ending the Zoom meeting for you to relax. We had just tackled the coverage for the your fourth mastery test. If you have question, you can raise it in our GC, or you can send it in my uh, personal message, or you can send it to a personal message. I think that'll do it for today, class. Grade 10, thank you for your participation. And good luck for your exam. Have a nice day. Goodbye.
Thank
Thank
you
you.
as well. Goodbye.
Goodbye.